Okay, so this is a data sheet from 2017, so I can't say for certain that you get given all this stuff in for the upcoming exam. You might get given more, but I can't seem to find an example of a data sheet that you'd be given in the upcoming exam. So what we'll do instead for the moment then is show, we know how to work out all of these ions on the left and all these ions down to here. All we do is we look at the periodic table. Actually, here's another complex ion that's, or compound ion or polyatomic ion that's positive. And this is one of the, in fact, there were two exceptions I think I talked about before where I said that almost all positive ions are metal, but here we can see a non-metal positive ion and another non-metal positive ion. The rest of them are metals. But let's have a look at. We can understand why hydrogen is a positive ion because it's in a positive one because it's in group one. Although they draw it over here, it should really be technically drawn here because it's got one electron in the outer shell. I think there are versions of the hydrogen ion which is a -1, and that's where it would fill the outer shell as opposed to emptying it. Well, it's only got one shell, in fact. So anyway, let's have a look at the first compound ion, the first polyatomic ion, ammonium. So you got NH4, and that is saying that it's a +1 charge. So how would we work out as a +1 charge? Well, nitrogen is in group 5. So we can, for now, just pretend that we know that nitrogen, because it's in group 5, is a, it's either a 5+ ion or it's a -3 ion or 3- ion. Because the hydrogens are, generally speaking, positive, then we're going to put it as the 3- ion. And then we've got the hydrogen plus, but we've got in this ion, we've got 4 of them. And so now we can see we've got an overall charge of 3- and 4+. The total charge is 4+ and positive, and 3- negative. And so, yeah, that's a 3- plus 4 is going to give us +1. Okay, so that's one of them, and this is basically how it works every time. Let's do hydroxide. Hydroxide is an easy one. OH, and let's pretend we don't know what the charge is yet. It's going to be made out of an O2- and an H+. All right, this is not a reaction. This is just a way of thinking about it. So I don't want to put plus to cause any confusion. But yeah, so we've got O2- and so as you can see, the 2-, and that's going to cancel out to form OH-. We'll do one more. I'll do the sulfate ion because it's one of the harder ones. So SO4, and we want to know what the charge is. So oxide is going to be O2-. In fact, let's just do a 4 like that. So that gives me an 8- in total. And then we've got 1 sulfur. So now, because the reason why it's confusing, I guess, in this case, is because sulfur's all the way in group 6, but we're going to go ahead and give it a positive charge. Because if I gave it a negative charge, it's going to give me a hugely negative charge, right? Because it's already 8-. If I give it another, if I say sulfur is also 2-, then it's going to give us. We're going to say that this is a 10- charge. Well, it's not that, because part of this we can imagine is positive and part of it's negative. Oxide's definitely negative, so we're going to say that sulfur is positive, and if it's positive, it must be +6. Okay, so like that. And as you can see, 6 plus minus 8 gives us -2, or we write 2- like that. Okay, so that is a nice way to work these out in case you don't get given them. Okay.